How's it going, everyone? Andrew Robinson here, back at it with another Max MSP tutorial video. In this video, we are going to be talking about scripting. I absolutely love scripting because it is a very powerful and versatile technique to dynamically edit our max patch. Anytime there's some kind of limitation you run into, which may happen depending on some obscure thing you may be trying to do with your patch, maybe the object just doesn't let you work in the way you want it to, you can make things work with scripting. That being said, it can get pretty messy as it works with a lot of scripting names, and there's a lot that has to be kept track of and sent out through messages in the correct order. It gets weedy, I will admit. So for that reason, I would say don't really rely on scripting, but it is powerful to know and very helpful when you kind of get stuck and you have no other solution. So let's look at how scripting works and jump right into the patch. First things first, we have to create a thispatcher object. Thispatcher talks to the patch. That is the function of this object. And if we right click and click open help file, you'll see in the help file for thispatcher, there's a lot of stuff thispatcher can do, but down here, there are these sub patches called scripting. And these give you very cool examples of how scripting works in Max MSP. You can connect patch cores between two objects. You can disconnect the patch core between two objects. You can click over here and create new objects, and any object that you want to create, if you want to assign arguments to it in the creation of that argument, you just type those into the message box as well too. You can delete objects if you wanted to, and you'll see everything starts with script and then some kind of scripting command. So it's like script connect, script disconnect, script new default with a variable name in a certain position and the type of object that it is. And these are also further examples of showing that script new default creates a new object. You're giving it a scripting name, a position, the type of object, and then all the attributes about the object. So it's super powerful for that way. And you'll see here with this script delete message, you're just saying script delete scripting name. So that is how it knows how to work with the object. And if you want, you can click on this object up here, open up the inspector tab, which I did by command clicking I. You can also click this I icon over here. If you scroll down in it, you'll see that scripting name for this object is var1. So if you want to enter your own scripting name for an object and then manipulate it through the scripting messages, that's how you can assign a scripting name to that object. Just click, open up the inspector file, scroll down to scripting name, and type in that name right here. Back in the main help file, you'll see there's so many scripting messages that there's even a second sub patch for all these scripting messages. You can hide objects or show objects. You can move them around to different positions in different ways. You can change the size. Anything that is a parameter or argument or attribute of an object that you can change, you can also change it through scripting. It lets you have full access to the object in any way you want. That is very powerful for so many different use cases. And so we're going to use this scripting to just create some simple stuff and show how this works. So we saw in the help file that it was the script new object message that creates new objects. So if we type in script and we say new object, and we say what we want the object to be, so it could be any object, button, toggle, trit.world, whatever you want. You're just going to type that in here. So let's create a button, and then we'll have to assign a variable name and a patching position, but we'll get to that in a second. I also have to spell button correctly, and if we patch that message into this object, lock our patch, click on it, there we go. We now have a button created. I can click this message again, and look, we get another button, and so on and so forth. And with this, we can define our attributes as well. So we could say something like patching underscore position, which is the attribute argument to determine the position of the button. And so we're just going to put some variables in this right here to get started. Let's create a pack object, which will give us a list. We'll define this as II for two integers, and we'll create two number boxes, and we'll assign a random value to that. And I just made so many buttons. So you'll see right away why this is messy. I just moved that number value, and now we're just generating a row of buttons, which actually, you know, is pretty cool. Let's get rid of this C and draw it this way. And look, we've now created an Etch-a-Sketch of buttons in Max MSP, which is pretty fun, I must say. You can already see why this is both very valuable and also very messy. Let's unlock the patch and delete all of these. And rather than just clicking and dragging in the number box, we'll use a random object to assign a random value. And I'm going to say 640 by 960. And that is because the size of this max window on my computer is 1280 by 960. However, I only want it to generate buttons on this half of the patch so we can do our coding scripting stuff over here and they won't accidentally overlap or anything. And that is the easiest way for me to do that. And then I'm just going to press B to create a button. Seems kind of archaic now that we're using scripting, but I'm going to patch that into the random objects, lock the patch, click this button, and we generated 2 because I got rid of the C for the Etch-a-Sketch. Let's put that C back in there. And now it will only create 1 button. And bam, every time I click this button, we get a new button created. So that is pretty cool. However, we are losing our ability to effectively communicate with these buttons further. Because you see, if I click on any one of these buttons and open up the inspector tab, we haven't assigned a scripting name. So we don't have any further way of communicating with these buttons. We couldn't tell them to do other stuff because they don't have scripting names. So that's kind of an issue, and we have to create scripting names for these objects in the generation of these objects. So the easiest way to do that would be to give the object the attribute variable name, and we'll say $3 here. Actually, for simplicity's sake, I'm gonna move all this stuff around. We'll have our variable be our first in our list, and we'll have the patching position be elements 2 and 3. This will just make much more sense once we start building up even further. And so we have already our patching position, but we do need to include a variable name in this. So let's create a name. The easiest way for us to do this that I have found is to use this object combine. And all it does is combine multiple different elements that are patched into it into one cohesive message symbol word that is just one word. So if I were to do something like, let's think of a name for our buttons. Let's just call them buttons for simplicity's sake. And we'll say buttons, period. And then we'll do a 1. We now have 2 inlets, and whatever goes into either inlet will replace that message there and then combine it. So what do I mean? If we create an integer box, which I did by pressing I, and I'm going to say trigger bang integer, we'll pass the integer out to this, which will replace the 1 in our combine message, and then we'll send a bang here, which will tell the combine object to output. And now we'll see we're getting, every time I change that, it's something like buttons.14, whatever this number is, buttons.15, 25, 30, so on and so forth, up and up and up. And we can use this as the variable name for our button object every time we create a new button. So to do that in the best way possible, we are going to need to join the name and our random patching position variables together into one list. And then every time we click this button to generate that info, we also need it to count up and create a new button for us and give it a scripting name. And if we do that, it'll generate the random position first. That'll get set here. Then it'll hit this counter. We'll count up by 1. And we will create the name for it here. And then that will output here and create the object with the scripting name. So let's see that in action. I'm going to click the button. Bam, we have one button down here. And if I check in the inspector, you'll see it says scripting name is buttons.0. If I click it again, we'll get a new button over here, buttons.1. Yep, so on and so forth. And I can click forever now. basically as many as I want, and we have all of these here. I think this was the last one I created. Yeah, that says buttons.30. We're on 30, so it's working out. And if we wanted to, we could do something crazy, like connect all of these buttons together. Let's figure out the best way to connect all the buttons together. And I think first things first, actually, in order to do that, we need to save these names of these objects in a very nice list that we can access. And actually, I've found that a really cool way to do this is using the col object, which we've talked about in a past video as well. And I'm going to just call it scripting names. And basically what's going to happen is we can store these scripting names inside our col object. To do that, to store something, you just have to send it the line as the first number that you want it to be stored on in the col object, and then whatever you want to store. So this says 1, and then it's these just data. I click that. We open this col by double clicking on it, and you'll see on line 1, it's got the data stored now. So we can use that to store our names pretty easily because we are already getting a number and everything we want to store. We just need to combine these two elements together. So I'm going to use another join message, and in this instance, I think I'm going to say triggers 1, which turns this into the hot inlet instead of this one. You'll see this is blue now. That's a cold inlet. It won't output when it receives its data, but it will output here. And the reason we're doing that is because we first are going to end up setting the integer number here, which is coming from the count, and then we want this data to be stored in our col objects. I'm going to very quickly Control A, delete everything, Control Z, undo it, and then actually also get rid of all these buttons. Everything's now basically reset back to 0 as if we just opened this patch. And I'm going to click a button, and there it is. We're still generating buttons. All that's working. And if we double click on our col scripting names, we'll see now we have on line 0 is button 0, and it's that position, buttons 1 on that position. So this is just super useful because now we can create as many buttons as we want. And again, all their names are being stored in here along with the position that we generated them at. So that's really useful. If we want to, we can now use this information to connect all our buttons together. And because we put it in a col object, one thing that's really cool about col is you can create a copy of it, and because it has the same name as this one over here, it accesses the same data. So we can also retrieve information. If I just enter that in some number, we'll get line 7's data out. So that's super cool. And we can now copy this all over the place and have it work and do whatever output we want here and affect all this scripting stuff and do its function there without worrying about overwriting anything here or ruining it or having like several patch cords coming out of it. It just keeps things really nice and neat this way. So with that, I'm going to take this other col object and we are going to say dump, which will tell it to output everything it has. And if we click dump, you'll see it says only buttons.36, but if we actually go to the Max console and we type in the object print and we click dump now, you'll see everything gets output, which is awesome. That's exactly what we want. But in this instance, to connect all these buttons together, we actually don't need to worry so much about the patching position. So I'm going to use the object ZL slice, which slice a list into 2, and I'm going to say slice 1. It'll slice the first element of this list and output it here, and everything else will get output out this second inlet. And we really only want that first value, that button name. So this is a nice way to do that. We'll see that work. I'll attach it into this message box. And now when I click dump, you'll see, yeah, we're only getting the name, which is great. So we'll take that, we'll take the name, and we're going to then use the object thresh, which thresh combines everything it receives within a certain time limit super quickly and combines them all into a list. So if I patch the thresh out to the right inlet of the message box, click dump, you'll see we now have a list of all our button names. Also very useful, because now we can run this into something like a ZL length object, which would tell us the maximum amount of numbers in this list, which is 37. There's probably a few different ways based on the setup that we could get this value, but I like doing it this way because it just doesn't interfere with anything else we've got going on. So ZL length, cool. We have the total number of values in our list, which there's 37 buttons. And so to connect one button to the next, if we look back at the help file of thispatcher, which was under in the scripting subpatch, you'll see it says script connect scripting name 0 to other scripting name 0. And what this is doing, this 0 here, is saying which outlet to which inlet do you want to connect. 0 being the first, because counting in computer programming, a lot of values start at 0. So 0 is the first outlet, and we're saying connect the first outlet of variable 1 to the first inlet of variable 2. And if you click that, you'll see, yes, in fact, it connected that first outlet of our variable 1 number box to the first inlet of our variable 2 number box. Perfect. And that's exactly what we're going to do right now. So because we're only connecting the first outlet to the first inlet, that's pretty easy. But we need to tell it to connect button 0.0 to button 0.1, and then button 0.1 to button 0.2, and then button 0.2 to button 0.3, so on and so forth. So we need the previous number to carry it over. And the best way, I think, to do that in this instance is going to seem a little complex, but it will also make a lot of sense. We're going to use the Uzi object, because Uzi, if you don't know, sends out a set number of bangs depending on the value defined in here. You could say something like 10, and then if you send it a bang, you're going to get 10 bangs out of this outlet as fast as it possibly can do. And we're going to assign the total number of scripting names in our list to that Uzi. And that's because when it gets a bang and sends out all those values, out of this rightmost inlet, you also get the current index, which is the number that Uzi is on. So if we set this to 37 by clicking dump, and I click and send this a bang, you'll see it says output 37. If we connect this into a print object, and we look at our console again, and click the button, you'll see we get a number 1, 2, 3, 4. So we get, basically, it counts all of the bangs for us. And so this is super useful for creating a list of values from 1 to whatever you want to go to. And we can similarly run this through a thresh object and into a message box, and we'll see we're getting all of those values now as a list. So that's perfect. That's exactly what we need, because we're going to take these values and we're going to make a new list from them that will give us the connection order in the way that we need it to work. So to do that, we're going to do a little bit of math. We're going to say vexpr, and we're going to say $F1 minus 1. And if I just take this message box, I'm going to disconnect it from the thresh, patch it into the vexpr, patch this out to the right inlet of the message box, and click it, and you'll see we are now subtracting 1 from every value here. So we have 0 where the 1 is, 1 where the 2 is, so on and so forth. It just subtracted 1. And what we should be able to do from here is now lace these two together using the ZL lace object. So if we connect this thresh here and this here, then in this output now, when we click this button, it should... Oh, that's because I disconnected this. Okay, that worked. It's just backwards. We want this one in this inlet, and this one in this inlet. Right? Yeah, this is what we want. So what ZLace does is it interlaces the two lists together. So it takes one from one list, then one from the next list, sticks them together, one from the first list, one from the second list, sticks those two together then, and creates a new list of these interlaced in that way. And for us, it creates exactly the order we need things to go in. It goes from 0 to 1, 1 to 2, 2 to 3, 3 to 4, order that we want our buttons to connect. But we need to use it through the scripting names, not necessarily the number that the button is. So to do that, we can actually create a new list using the index map, which is a pretty cool way of doing this. And basically, if we send it a list here, and then we send it a list here, which I can demonstrate by also patching in these message boxes and just clicking on them for right now, we will tell the ZL index map object to create a new list of the values from this list based on the input of this list. So it's going to see 0, 1, 1, 2, 2, 3, and it's going to take the 0 here and the 1 here and make a new list, but then it's going to take the 1 and the 2, so it'll add a second button 1 in there. It'll make much more sense once I click on these. And there we go. I clicked on it, and you'll see it's done that. It's created this list to match the number of this list. So it goes button.0 to button.1, button.1 to button.2, button.2 to button.3. Perfect. Exactly what we want to connect all our buttons together through scripting messages. So I'm going to create an object, and we don't actually need these message boxes here anymore. That's just for display purposes. Because these object outputs are still connected, they will perform their function when it's done. So we'll take this and we'll say script, and we'll say script connect because we want to connect the patch cords, and we'll say $1 for our first variable, and we'll connect its outlet to $2, which will be our second variable, and we'll say 0 for its inlet. So it's going to take element 1 of a list, connect its outlet to element 2. And we can't just straight up connect this whole list because this is element 1, this is 2, this is 3, this is 4, 5. We need to slice this out into its own lists that are going to do this in the correct order to match these variables. So it's actually really easy to do that. We are going to use another ZL object, and it's called ZL iter. And if you type in a number 2, it's going to slice an incoming list into smaller lists in groupings of the number you define. So because we set ZL iter 2, it'll slice them into lists of 2 values, which is exactly what we want for this, and we've set it up to work with this list that way. So let's create a print object. Again, I'm going to detach this message box, but patch it into our ZL iter object. Let's open up our console real quick, clear it, click this message box to send that through, and you'll see we're getting a list of 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, so on. Exactly like we want. And if we just patch this into the script and this into the thispatcher now, we can click this message box and bam, all our buttons have now become patched together just like that. And it's beautiful. What a web we have created. So let's clean this up and make it look nice and neat and make sure that it works if we want to add more buttons. So this is our add a button, and I'm going to click it, and we're going to add several more buttons. These buttons are now stored in our col object over here, which means they'll also be stored in our col object up here, which is perfect. And this is all going to work. So we just need to make sure that pressing this dump button outputs the order object of all these in the correct way. So let's use a trigger object to make sure that happens. We first want to dump everything out and combine everything into one list. We then need to get the number of the list length here and then a bang here. So this does this operation and sets it here, and then pass that list out to the ZL index map. So actually what we're going to do is ZTLBL. And we're going to connect these patch cords here to this leftmost inlet because this will be the last thing to do its order operation. And take this one, patch that into our rightmost inlet because this list will come out here through this outlet that's labeled list. And it's going to do this ZL length calculation. Then we're going to get an bang out of this one because the B turns it into a bang. We'll have that hit this button for the Uzi to do its thing, which, like I said, we'll set the index map down here, and then we'll pass our list out through here one more time to recreate its own list and iter, and then tell them to connect. So you'll see there are buttons floating around now that we just added that don't have their connections, and now when I click this dump message, they will get their connections made, just like that. I did have to double click though. So let's refine this further so I just don't have to double click. We'll pass this list into this. The list will come out here. That bang will do that. Okay, so I had to double click to get it to work, and the reason for that seemed to be some sort of timing error that was happening. I was able to fix it though, just by adding in this little buddy object. And what it does is it takes the inputs and it doesn't output them until it's received some sort of input in both of its inlets. So it synchronizes the timing of arriving data, which is exactly the issue we needed fixed. So this is coming in and it's going to wait until it receives a list here, and then it will output, and it's going to output this one first, which needs to be output first for our ZL index map to work. Then the list is going to come out of here and create a new list and then iterate through correctly into here. So we can see that'll work one more time. If I quickly delete these objects to reset them, and we just click and add a bunch of buttons in here and generate tons of them. I'm just gonna keep going, keep going, keep going, keep going, keep going, keep going. Okay, now I'll stop. And now we'll click dump, and there we go. We've connected a lot of them together. You'll see there's just a couple out here that are floating, and I think the reason for that is because the ZL objects cap out at 255 values in their list, and I think there's a bug with them where even if you change the maximum attribute on this from something to something higher, it doesn't actually work here. So aside from that one bug of the ZL objects, this patch is working pretty perfectly. And that's basically it. If we wanted to, we could easily delete all of these as well. I may as well show that real fast, even though, I'm sorry, this video has gotten a lot longer, probably a lot more convoluted than I had originally intended. But real fast, let's show the deleting of these objects too, so you don't have to click and highlight and delete everything to reset this. So to do that, we're going to use the script delete message, and we just need to give it the variable names of everything to delete. So we're gonna recopy this message, which has all our variable names in it. Actually, let's copy it with all of this included, because we, again, only want the variable name. We don't need the position value necessarily in this instance. And it's just going to, when we click dump, slice all the variable names out and delete everything. And with that, we should probably also make sure that we clear the names out of the coil objects, just so it doesn't confuse the coil objects when we go to add more. So the best way to do that would probably to be add another trigger object in here, and we're going to say t clear L for list. That list works as this message symbol. So when I click dump, that'll dump message will come out here and tell the coil to dump all the variable names, and then it will send a clear message out this outlet to remove all of those names from the coil. And so I'll click this, and boop, it did in fact delete all of them except for just one little guy. Aw. Aw. And that's because for some reason he was a duplicate. Aw. And that's another reason why scripting can actually get pretty messy, is because even if you think you're doing everything right, sometimes little guys like this sneak in there, and then the more you start scripting them in and not actually removing them or something, the more you just have random objects and stuff floating around your patch. So it can get pretty messy, and again, this is why, this is really kind of like a last case scenario technique when doing coding work. But you can see also why it's super useful. Let's have this reset our counter to, we can do that by passing a 0 through to this, and that'll work there. And now everything should be fine to just click on and add or delete or whatever, as many buttons as you want up to the limit of the ZL that it allows. Bam, dump, connected them all together, dump there, cleared them, and then we can click the button again and add more. Connect, delete. And that's pretty fun to play with. Hopefully you guys learned something from this video. Like I said, I know this technique is confusing, it's complicated. Hopefully this at least makes sense and you can kind of grasp some basic concepts of it enough to get started doing it on your own. And like I said earlier in the video, basically scripting lets us edit the patch dynamically in any way we want. So anything that you can do in Max through editing and literally typing in new objects and creating code, you can do through scripting. So it lets you create a lot of unique solutions to problems you may run into with the limitations of some objects and really niche use cases where you are trying to make something work and there's just no possible way for it to work. You can make it work with scripting. And hopefully this doesn't scare anybody either, because like I said, I know this is messy and confusing, but if you learned something from this video or found it helpful, please let me know. The best way to do that, leave a comment, like, subscribe. That's how I know you learned something. If anyone's still confused about anything, please also feel free to leave those questions in the comments down below. I will answer them if and when I can, and I will see you all in the next video. Thank you so much for watching. Goodbye.